When we did our chromatography prac, where we were looking at the ink that was on the threatening note, we noticed that even though they were all black inks, they all had different patterns of colours spreading out when we put them through the chromatography tests. And the funny thing is, they all had the same colours in there, some of them, but even the colours themselves spread out in a different way. And the question is why? If they're made out of the same colours, why do they even spread out in a different way to each other? What's different in there that gives them that unique physical property? And it all comes down to what they're made out of and how it's organised. So you better write this down. Why do substances have these physical and chemical properties which are unique to them? What particles they're made out of and how those particles are organised. And so this is where we get into the discussion of what is a particle, and it all leads to atoms, elements, and the periodic table, because that's where we have to start. Because when you think about it, the very basic thing that everything is made out of around us are particles called atoms. Now these are the building blocks of everything around us, of all matter. Now they themselves are built up of smaller pieces, but in essence the basic building blocks are called atoms. And that's what you're going to be investigating now. Now, there isn't just one type of atom or a few types of atoms. There are lots of them. We're over 100 already and finding more as we go. And you find out about these atoms on this periodic table, which I'm sure you've seen around all over the place. The periodic table of elements is so important that to most scientists, especially chemists, it's called their chemical Bible. Okay, it is that important because it talks about all the different types of atoms that we know, and this is not just on Earth but across the universe that we can see so far. And it organizes them based on actually their behavior, because every single one of these atoms has its own unique properties and its own unique behaviors, and because of that we can organize them and also predict what they're going to do based on what type of atom they are. Now we break them up into some very basic groups here. Okay, over here, well, pretty much most of the table, okay, all of this and pretty much all of these guys are metals. Okay, they're the metals. So these atoms have all of the different physical properties, or most of them, that a metal has. They're malleable, they conduct electricity, they conduct heat, they have luster, all of those properties these guys have. Now on the other side of the periodic table, over here, we have non-metals. I'm just going to put NM there for short. Now the non-metals are basically the opposite of the metals. They don't conduct electricity, they don't bend, they break, they're not malleable, they're dull, not shiny, all of those things. We call them non-metals, and they're basically the opposite of metals. Now right in between the two, we have this little line of guys here that sort of bridge the gap between the metals and the non-metals. They actually have properties of both, so we call them metalloids. Now, one of the other things I'll point out here is this lovely little column over here. These guys here are called noble gases. They're non-metals, but they're so happy and so stable that all of them are gases. And we use these an awful lot around the place. You'll notice there's helium, there's neon, there's argon. All of these guys are gases that we often use in society, and we use them in, say, our street signs and helium balloons and stuff. And they're called noble gases because these guys are so happy that unlike every other atom on that table, they're quite happy to exist all by themselves. They don't want to join up to anyone. They don't want to be organized. They are quite happy floating around all by themselves. And that's why we call them noble gases. Other than that, I'm not going to ask you to remember much more at this stage.